Example 2 of solving expressions by looking at sign tests. The first step is to factor both the numerator and denominator to look at your zeros and asymptotes. And so as I look at this numerator, I can factor this down using g plus 7 and g minus 5. In a similar way, as I inspect the denominator, I recognize that the two numbers that multiply to give me 12 and add together to give me 8 would be 6 and 2. So I can call this g plus 6 and g plus 2. Once you have both the top and the bottom factored, we look for what we call critical points. Critical points come from zeros, which are located in the numerator, and restricted values, which are the zeros from the denominator. And so I'm going to have my number line here. My zeros from the numerator would be located at 5 and negative 7. So there's negative 7, here's 5. I'll mark a 0 above them. Restricted values come from negative 6, that's what creates a 0 in the denominator, and negative 2. And once again, we'll call those DNEs for asymptotes, restrictions, values that we cannot have. And then the concept is to find all the values that fall in between these criticals to see whether we fall above or beneath the x-axis, and then we can inspect that to answer when it's less than or equal to 0 or when it's negative. And so I'm going to choose a number that's clearly not near negative 7, so let's try something like negative 10. If I plug negative 10 in here, the results would be negative, 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 negative. 4 negatives results in us having a positive value. So if I were to graph this, it would be above the x-axis anywhere before or preceding negative 7. Try a number between negative 7 and negative 6. Try something like negative 6.5. The result would be positive, negative, negative, negative. 3 negatives means that the expression would graph beneath the x-axis. Try a value between negative 6 and negative 2, say negative 4. When I plug it in here, I get positive, negative, positive, negative. 2 negatives create a positive. And then, of course, to check between negative 2 and 5, the obvious choice would be to use a 0. As I plug a 0 in, I can use the values that I see here. So this would be positive, negative, positive, positive. Result is negative. And last, try a number greater than 5. So 30 million. 30 million plus 7 is positive. 30 million minus 5 is positive. 30 million plus 6 is positive. 30 million plus 2 is positive. 4 positives would be positive. For example 2, where it differs from example 1, we're looking for anything that is less than or equal to 0, meaning that we're looking for the negative regions. And so if we're looking for anywhere that the expression is graphed beneath the x-axis, we can start here. I can have negative 7. You see that's a 0 value. So I would start with a bracket. This would run all the way up to negative 6. I cannot have 6. It doesn't exist there, so I cannot contain it. And so I would use a parenthesis. Union, as I look to my next negative region, and I would do parenthesis for negative 2, because once again I cannot contain that asymptote. And then it would go all the way up to 5. Because I can contain the 5, it's equal to 0 at 5, I'll put my bracket. And that would be my interval notation for when this expression is negative or beneath the x-axis. Those would be how you do examples 1 and 2 from your test.